The Australian Astronomical Observatory (AAO), formerly the Anglo-Australian Observatory, is an optical and near-infrared astronomy observatory with its headquarters in North Ryde in suburban Sydney, Australia. Originally funded jointly by the United Kingdom and Australian governments, it is now managed wholly by Australia's Department of Industry, Innovation, Science, Research and Tertiary Education. The AAO operates the 3.9 meters Anglo-Australian Telescope (AAT) and 1.2 meters UK Schmidt Telescope (UKST) at Siding Spring Observatory, located near the town of Coonabarabran, Australia. In addition to operating the two telescopes, AAO staff carry out astronomical research, and design and build astronomical instrumentation for the AAT, UKST, and other telescopes including the European Southern Observatory (ESO's) Very Large Telescope in Chile, and the Japanese Subaru Telescope on Mauna Kea in Hawaii. UK involvement in the AAO ceased in June 2010, with the change of name and management arrangements effective from 1 July 2010. History. In the years immediately after World War II, optical observational astronomy in the UK was toiling due to a lack of modern infrastructure. There were no large telescopes in the Southern Hemisphere despite some of the most intriguing astronomical objects, e.g. the Galactic Centre and the Magellanic Clouds, being best placed for study from these latitudes. In the 1950s, Richard Woolley, director of Mount Stromlo Observatory from 1939 to 1956 and Astronomer Royal from 1956 to 1971, suggested constructing a large telescope in Australia. After a series of meetings between British and Australian scientists in the early 1960s to discuss the technical specifications and begin the search for a suitable site for the proposed telescope, a formal approach was made to the governments of both countries in July 1965. It was finally agreed in April 1967 that the building of a 150 telescope, the Anglo-Australian Telescope (AAT), should proceed. The telescope was to be located on Siding Spring Mountain in the Warrumbungles, which was owned by the Australian National University (ANU) and the site of some of their existing infrastructure. Later that year, an interim body known as the Joint Policy Committee, and including prominent scientists Edward Bowen (AUS), Olin Egan (AUS), Richard Woolley (UK), and Jim Hosey (UK), was formed to oversee the early running of a project office which was located in Canberra. The project office finalised designs and specifications for the telescope, the mounting and the building, and let contracts on a worldwide basis, exploiting the experience of those staff members who were involved in the development and construction of the Parkes radio telescope. The Anglo-Australian Telescope Agreement was signed on 25 September 1969 and came into effect on 22 February 1971. The Joint Policy Committee was replaced by the Anglo-Australian Telescope Board (AATB), an entity with full legal status under Australian law with responsibilities of overseeing the running of the telescope. As construction of the AAT gathered pace, a heated debate ensued as to the details of the management structure which would control the telescope. Then director of Mount Stromlo and Siding Spring Observatories, Olin Egan, and then Vice-Chancellor of the ANU, John Crawford, claimed that the bi-national agreement did not provide for the creation of a separate observatory. They argued that the telescope should ultimately be under the control of the director of Mount Stromlo and Siding Spring Observatories and that additional staff for the new telescope should be provided by the ANU. However, fearing that they would be mere guests rather than equal partners in the AAT, British astronomers, with support from Australian State University astronomers, campaigned hard for a separate director and staff who were employed by and answerable only to the AATB. The matter was not settled until June 1973 when the Australian government endorsed the AATB's decision for an independent staff, marking the birth of the Anglo-Australian Observatory. The first director, Joe Wampler, took up his post in September 1974. To date there have been 5 directors. Construction of the Anglo-Australian Telescope. In late 1967 the contract for the primary mirror blank was awarded to Owens-Illinois Inc., USA, and the 27.5-ton structure was cast from zero-expansion Servet glass in April 1969. The blank was shipped to Newcastle upon Tyne, England to be figured and polished by Sir Howard Grubb, Parsons & Co. Limited. The final product has a diameter of 3.9 meters and a focal length of 12.7 meters. Construction of the building and dome, undertaken by the Australian companies Leighton Constructions and Evans Deacon Industries respectively, began in late 1970 and was completed by the end of 1972. The building was manufactured from concrete, stands 26 meters high and has 7 floors housing offices, labs and a mirror aluminizing chamber. The telescope stands on a concrete pier with a separate foundation to the main building, to reduce the risk of vibrations. The double-skinned dome is manufactured from both steel and aluminium and weighs 570 tons. The telescope is mounted equatorially, loosely following the design of the 4 meters Kitt Peak National Observatory telescope. The mount was manufactured in Muroran, Japan by Mitsubishi Electric. It was shipped to Australia in early 1973 before being assembled at Siding Spring Mountain in April of that year. The telescope drive system was also produced by Mitsubishi Electric and delivered at this time. It was one of the first to be controlled by computer, an Interdata Model 70, and provided new levels of pointing and tracking precision. Assembly of the AAT was completed by 1974 and commissioning of the telescope began in April of that year. In total it took 8 years to build at a cost of $16 million. It was inaugurated by HRH Prince Charles on 16 October 1974 and went into general use in June 1975. Research with the AAT. The AAO has made use of optical fibers in astronomy for over 25 years. Instruments such as R-Omega, and its predecessor 2 decifarads, use optical fibers to feed the light of stars and galaxies from the telescope into a spectrograph where it is dispersed into its component colors for detailed subsequent analysis. The broad field of view accessed by the 2 decifarads and R-Omega instruments, 4 times the width of the Moon, and the 400 optical fibers, makes it feasible to spectroscopically survey large numbers of objects distributed across expansive areas of sky in a reasonable time frame. A number of major studies undertaken with the AAT have exploited these capabilities. The 2 decifarads Galaxy Redshift Survey (2DFGRS) used the 2 decifarads instrument to obtain spectra and redshifts for approximately 250,000 galaxies brighter than B, approximately 19.5 over approximately 7% of the southern sky in only approximately 270 nights. The 2DFGRS sample size was an order of magnitude greater than those of previous surveys, allowing a rigorous evaluation of cosmological parameters. For example, the survey has refined estimates of the mass density of the universe, provided a determination of the fraction of baryonic matter in the universe and set an upper limit on the total mass of neutrinos. In addition, 2DFGRS yielded an independent estimate of the Hubble constant, which was in excellent agreement with value determined by the Hubble Space Telescope Key project. The ongoing WiggleS project is using the AAT and R-Omega to measure the redshifts of approximately 200,000 distant luminous blue star-forming galaxies distributed over an area of approximately 5,000 times the area of the Moon. The primary goal of this study is to use an intrinsic feature in the distribution of galaxies as a standard ruler to relate distance to redshift and improve our knowledge of the nature of dark energy. This mysterious component of the universe appears to be responsible for accelerating its rate of expansion. Another R-Omega-based survey on the AAT, Galaxy and Mass Assembly (GAMA) is in the process of obtaining optical spectroscopy for approximately 250,000 galaxies in the local universe. The R-Omega data will be used in conjunction with observations from satellite observatories such as the Herschel Space Observatory, and other telescopes around the world, to examine the predictions of the cold dark matter standard cosmological model, like the relationship between the number density of dark matter halos and their masses and the relationship between the number density of galaxies and their masses as determined through studying the starlight. The AAT also hosts a program to search for extrasolar planets, the Anglo-Australian Planet Search (AAPS). The AAPS exploits the high stability of the University College London Echelle spectrograph (UCLES) to obtain the few meters per second precision in measurements of the line of sight velocities of stars necessary to detect the reflex Doppler motion induced by the presence of a planet. The AAPS has found more than 20 extrasolar planets, with masses ranging from approximately 10% to greater than 10 times that of Jupiter. The Schmidt telescope. The 1.2 meters UK Schmidt telescope was built to complement the AAT and officially began operations in August 1973. It was designed for survey astronomy, having an extremely large field of view which is more than 12 times the apparent diameter of the Moon. The telescope was operated by the Schmidt Telescope Unit of the Royal Observatory, Edinburgh until 1988, when it was agreed that control would be handed over to the AAO. The Schmidt has undertaken work including blue and red photographic surveys of the southern sky and the 6 decifarads galaxy survey. Its multi-object spectroscopic capability is currently being exploited to perform the Radial Velocity Experiment (RAVE) survey. See also: Digitized sky survey, List of astronomical observatories, Sky survey.